Section P8.3 Answers to the questions on resultant forces. Question 1, they give you the diagram of the cyclist. They show the forward force and the backward force and the sizes of those. They ask for the resultant force. It's the difference between those two numbers. You have to give the difference and the direction. Don't forget your units. So the direction is always going to be the same as the biggest force. So in this case it's forward. Here they just ask you to work out the size of each force. This is 1, 2, 3, 4 squares along to the right. So we write that as 4 newtons to the right, and this one's 5 newtons to the left. Question 3. Two forces of 15 newtons and 36 newtons are acting on a body. Calculate the possible resultant forces and directions when the forces are acting in the same direction. You add them together. Gives us 51 newtons to the right, from left to right. In opposite directions, doesn't really matter which way around you do this, but you take the two numbers away. So the difference between them is 21 newtons. In this case, because I said the biggest one is to the right, I've drawn the arrow to the right. Question 2. A. What is the size of the resultant force on the car, showing you're working? Again, it's the difference between these two, and the largest force gives you the direction. So 1500 newtons to the right. Describe the motion of the car. Because the forces are unbalanced, the car is going to be speeding up or accelerating. And again, mention the direction. Okay. Aircraft, this one's got 4 forces acting on it. And they ask us what the resultant forces are and how will it affect the plane's motion. So we look at the vertical forces first. The lift is 30,000 newtons. The weight is 30,000 newtons. They're the same. So they cancel each other out. They're balanced. The horizontal forces, however, are different. So the thrust is 50,000, the drag is 20,000, the difference is 30,000, and it's moving forward. Because the forces are unbalanced, the plane will accelerate, so it will speed up. Looking at a box here with more than one force each side, all you need to do is add up both sides and the difference and the direction. So in this case, we've got 7 newtons to the left and the direction is left. Question 5. Here we have multiple forces acting. All I've done here is consolidate those, so I've just added them up each side. And then I've taken them away. So 15 take away 6 is going to be 9. And 18 take away 9 is going to be 9 down. So your resultant force is the diagonal between those two forces, because these are equal and opposite. It's that 45-degree angle between. Okay, motorbike. He's turning the throttle, so there's thrust, and he's got his brake on, so the friction is there as well. These forces are equal and opposite, so the bike isn't moving. So they're balanced. It will not move, it will remain stationary, okay, while those two forces are acting on it. However, when he changes the forces, the biker now releases the front brake, the bike's going to accelerate forward. And the different backwards forces now act on the bike. What are they? Air resistance or drag. So as he's moving through the air, those air particles are bumping into him. That's called air resistance. It slows him down. Eventually the backward force becomes equal to the forward force. So what's going to happen here? The bike's going to move at steady or constant speed. Question 7, another aircraft. Here they ask us to label the diagram. So we have upthrust or lift, gravity or weight, forward thrust and drag. The horizontal forces are the same, so it remains at the same height. The horizontal forces here and here The difference between them is 45,600 newtons, and it moves to the right because that's the biggest force. Last question, 8. The runner has 3 forces acting on them. So if you read through the text, you can label the diagram. Force of friction pulling her back, and the force from the wind and her muscles are labelled on there as well. We look at the differences between those, so we add the muscles and the wind forces together and we take away the friction force. Overall, it gives us 63 newtons forward. Describe and explain the result of these forces. The runner will accelerate forwards, so that will give you 1 mark. This is because the force is not balanced. Okay, and the resultant force is 63 newtons and the direction of the force. Okay, so 4 marks there. Summary: the resultant force is the single force that has the same effect as all the forces acting on the object. If this is 0, the object is stationary or travelling at a constant speed. If this is greater than 0, the speed or the direction of the object will change. It will accelerate. Okay, I hope that's been useful.